Have you ever watched an Olympic weightlifter and just, wow? I mean, in one single, explosive movement, they throw hundreds of pounds over their head. It looks like it's all about pure, raw strength, right? But what you're actually seeing is this beautiful, real-world display of some pretty fundamental physics. So let's get into it and break down the invisible forces behind one of the most powerful moments in sports.
It all really comes down to this one incredible question. How on earth does an athlete take the energy from, say, their lunch and turn it into the mechanical power to lift a 400-pound barbell? Well, it's not magic, I promise you. It's this amazing story about energy transformation, and we're going to follow that journey every single step of the way, from the bar sitting on the floor to that triumphant moment overhead.
Okay, let's start at the very beginning. The barbell is just sitting there on the floor, not moving at all. The crowd is silent. At this exact moment, the stage is set for a massive exchange of energy. But first, we've got to figure out where all that energy is hiding.
So the potential for this huge lift, it's not actually in the barbell itself. Not yet. It's stored inside the athlete. We're talking about chemical energy, which is locked away in the food they've eaten and processed. Think of it like the high-octane fuel in a car's tank, just waiting for the engine to roar to life. This is the ultimate source of every ounce of force they're about to unleash.
Now, the other key player in this whole story is gravitational potential energy. And this is just the energy of position. Put simply, the higher something is off the ground, the more potential energy it's got, because, well, it has farther it could fall. This is the energy that we're about to give to that barbell.
Right now, with the barbell resting on the floor, its gravitational potential energy is basically zero. I mean, it can't get any lower, right? So at this point, all that incredible potential for the lift isn't in the barbell's position. It's all coiled up inside the athlete's muscles, just waiting to explode.
And here we go. The lifter gets their grip on the bar. You see the muscles tense up. This is that first phase, the first pull, where the athlete starts to do work against the constant, relentless downward pull of gravity.
We use the word work all the time, but in physics, it's very, very specific. You only do work when the force you're applying actually makes an object move over a distance. So the whole goal here is to do enough work to get that barbell all the way from the floor to high above the lifter's head.
This little diagram on the left gives us a great picture of the forces at play here. You've got the barbell's weight, which we see as W, pulling it down thanks to gravity. To even budge it off the floor, the lifter's upward pull, labeled T, has to be stronger than W. It's literally a tug of war against the entire planet, and for this lift to happen, the lifter has to win.
So getting the bar off the floor is one thing, but the part of the lift that just makes your jaw drop is that explosion. That moment where the lifter just seems to defy gravity. And this isn't just about work anymore. This is about power.
Power is the real game changer here. It's not just about how much work you do, but how fast you do it. I mean, anyone could probably figure out a way to lift 400 pounds over the course of a minute, but to launch it overhead in less than a second, that takes an absolutely incredible amount of power. To generate that kind of insane power, the lifter has to accelerate the barbell. They have to make it go faster and faster. Just look at how steep that slope is on this velocity time graph. That steep line is the signature of explosive acceleration. It's a moment of pure, focused force converting into incredible speed. As that barbell accelerates, it gains a whole new kind of energy, kinetic energy. This is the energy of motion. And here's the crucial part, the secret sauce to this whole thing. The formula is 1/2 times mass times velocity squared. That little squared symbol? Oh yeah, that changes everything.
Because velocity is squared in that equation, the relationship isn't a straight line, it's a curve. This is the aha moment, so listen close. If you double the barbell's speed, you don't just double its kinetic energy, you quadruple it. This is exactly why a lifter's technique is all about generating that explosive whip of speed. They are pumping a massive amount of kinetic energy into that bar in just a fraction of a second.
Okay, let's fast forward to the peak of the lift. The barbell is overhead, and for a split second, it's just hanging there. Its journey upward is done. But wait, what happened to all that kinetic energy? All that energy of motion seems to have just vanished.
But it didn't vanish. It was all part of a grand bargain, an energy exchange. During that explosive upward blast, the barbell's kinetic energy was at its max. But now, at the very top, its potential energy, that energy of position, is at its absolute peak. A trade has been made.
At its highest point, the barbell's velocity is, for an instant, 0. It stops going up for just a split second, before gravity starts to pull it back down. And if the velocity is 0, then its kinetic energy must also be 0.
So where did it go? Well, the work the athlete did transformed their chemical energy into the barbell's kinetic energy. Then, as the barbell flew upwards against gravity, all of that kinetic energy was perfectly converted into gravitational potential energy, which is now stored and waiting at the top of the lift.
This brings us to the beautiful conclusion of this whole energy story. Everything we've just seen, from the chemical fuel to the work, the motion, the height, it's all governed by one of the most fundamental laws in the entire universe.
The source material says it perfectly. Mechanical energy must be conserved. What does that mean in plain English? It means energy can't be created out of thin air, and it can't be destroyed. It can only change from one form to another. The total amount of energy in this system stays the same throughout the entire lift.
So let's just recap that whole journey one more time. It starts as chemical energy in the athlete's muscles. That fuel is used to do work on the barbell. That work gives the barbell kinetic energy as it explodes upward. And finally, that kinetic energy transforms into potential energy at the peak. It's a perfect, unbroken chain of transformation.
So, an Olympic lift is really just a story about energy. It's a narrative that flows from food to muscle to incredible motion, and finally, to a state of pure potential at the top. The energy is never, ever lost. It just changes its form, telling a different part of the story at each stage of the lift.
And that kind of leaves us with a final thought, doesn't it? This incredible, very visible display of physics is actually happening all around you in invisible ways, all the time, from a bouncing ball to a pot of boiling water. So the next time you see something move, or stop, or change, ask yourself, where else in my day can I spot that invisible transfer of energy?